So my topic to discuss is what is masonry, its history and materials used in masonry construction, concrete hollow blocks or the CHB, the calculating the required CHB, the mortar, the CHB footing, the plus the plastering, and lastly is the brick masonry versus the stone masonry, the difference between the two and their individual characteristics. So what is masonry? Masonry is a term. The term masonry refers generally to brick, tile, stone, concrete blocks used in masonry construction. So the art of masonry originated when early man sought to supplement his valuable but rare natural caves with artificial cave made from piles of stone. Like Egypt had developed an elaborate stone masonry technique culminating in the most extravagant of all ancient structures, the pyramid. The choice of masonry materials has always been influenced by the prevailing geological formations and conditions in a given area. Egyptian temples, for example, were constructed of limestone, sandstone, alabaster, granite, basalt, and porphyry quarried from the hills along the Nile River. Many architects value masonry for its color, scale, texture, pattern, and look of permanence. In addition to its aesthetic appeal, masonry has a number of other desirable properties such as its value in controlling sound, resisting fire, and insulating against daily fluctuations in temperature. So masonry versus mason. What's the difference between the two? So masonry, I said earlier, is a construction of building units such as stone, bricks, or concrete blocks, while the mason is a skilled tradesperson who works in the masonry profession. They are the one behind in masonry construction. So, concrete hollow blocks or CHB is that they have two types. The load-bearing blocks are those whose thickness ranges from 15 cm to 20 cm, and the non-bearing blocks are those whose thickness ranges from 7.5 cm to 20 cm. 7.5 cm to 10 cm. So CHB has a total of 4 cells. You can see in the image. It have a 3 whole cell, then the end have half cell added to the one at the end, a total of 4 whole cell. And this is in computing the required materials for the CHB. The estimator has to consider the following items like the quantity of the concrete hollow blocks, the quantity of the cement, sand for blocks, laying mortar, the quantity of the cement, and sand for mortar to fill the hollow cell at every block, because we know that CHB have 4 cells. We need to minus that 1. Then the cement and sand required for plastering, and 2 sides of the blocks, since plastering involves 2 faces, the front and the back. The materials for CHB footing and the steel reinforcement, which will be topic in the next chapter, and other factors that might affect the estimated quantity of materials like the improper measurement of aggregates. Sometimes the mason prepares a box for measuring sand, gravel, not in accordance with the specified measurement. The excess mortar, that are the factors that can lead to some mistakes for the estimated materials. Next is the computation. This is the hardest part in computing for the required CHB in a structure. So for figure 2.2, the image to the right, determine the number of 10 by 20 40 cm concrete hollow blocks and the required materials for mortar for block laying, mortar for plastering, and footing using class B mixture. This 10 by 20 by 40 is the volume dimension of the CHB. The 10 is its thickness, 20 its width, and 40 is its length. So first is we will need to concrete the hollow blocks, the required hollow blocks, given the fence, the dimension of the fence, and the CHB footing. So first is divide the height of the fence by the height of the one block. Since the height of our fence is 3 meters, we'll just divide it by 0.20 from the 20 width of the given hollow block, convert to meters, so 0.20, which will now we have the value of 15 pieces. Each layer, 15 pieces. Next is divide the total length of the fence by the length of one block. Since our total length for the fence is 20 meters, which is 8 plus 8 plus 4, 20 meters, divided by the length of the our CHB, which is 40 centimeter to 0.40 meters, we have the 50 pieces. So 15 pieces upward of CHB, then 50 pieces and the length CHB required in the given fence. We will just multiply the two to get the total pieces of hollow blocks we need. And the answer is 750 pieces. Next is calculate the mortar for block laying. Mortar is the one that we will use to paste. It's like a glue to hold the CHB together. It is given here the average thickness is at 0.0125 meters. First, find the volume of the mortar just in one layer. So we have the thickness given. The width of the, we will use the width of the CHB, which is 0.10 meters. It's given, which is 10 centimeter. Then multiply to the total length of the fence, which is 20 meters. You'll have the value of 0.025 cubic meters. Then multiply by the number of layers to get the total volume. So the total layers we calculated earlier is 15 layers because it's 15 pieces. Then multiply it by the volume we get in the one layer in volume for the mortar. The answer is 0.37 cubic meter. Then refer to table 2.1 using class B. Just get the volume. We have the volume, then multiply based on the table given. We will get the required bags and the volume for the sand. Next is mortar filler for hollow cells. It is given here the dimension of the cell for the CHB, which is 0.05 and 0.075 and 0.20. Calculate its volume. Since we know that the CHB have 4 whole cells, so just multiply the volume by 4, then we will get the volume of 4 cells per block. This is just per block. And the total volume for cells of the required 750 CHB, just multiply the total the volume of our cell, then multiply to the 750 pieces of CHB. Now we have the 225 cubic meter total volume of cells, 750 CHB. Then again use the table, then multiply using the volume we got. Then next is the plastering at an average of 16. Given the thickness of the plastering, first find the area of the fence. So one side, example is the front side. So 3 meters its height and 20 meters is its total length of the fence. So calculate, we have 60 square meter. Then find the area of the two sides, just multiply by 2 the one that you got in the area of the fence in the one side. Then you can get the total area in two sides. So for the volume given the thickness and multiply it by the area, the total area, we will have the 1.92 cubic meter. Then refer again to the table, then we can calculate the cement and the sand. And last is the footing. In solving the volume of the footing, just use the image. The thickness, which is the height, again, is 0.15 and width is 0.40, and the total length, again, for the fence, we'll use the total length of the fence, which is 20 meters. Then multiply the 3, then we have 1.20 cubic meter is the volume of the footing. So this is the summary of the materials we calculated. And using the table 1.2 in the previous lection, we will calculate for the class B concrete 40 kilograms. Just use the volume we calculated, multiply this based on the table given values, then we can calculate for the required bag, cement, and the volume for sand and gravel. So summary, concrete of hollow blocks 750 pieces, 40 kilograms of cement, say 64 bags, then sand is 5.145 cubic meter and gravel is 1.20 cubic meter. And next is the other way to solve the CHB required CHB volume of mortar is this. We have the 4 tables we needed. This is the easier one than the other. This is the example. Here we have the fence. Its dimension, and it have a post which is its dimension of the post is squares. So they have the same dimensions, which is 0.20, and we have here the footing of the post and also footing for the CHB. It is different. So we will calculate the volume of the footing of the post, calculate the footing of the CHB, then we will calculate many things. First is calculate the concrete hollow blocks. Then we have here, first is find the perimeter of the fence. We have here the 25 by 25 by 25 minus 5, which is the rock 5 meters, so 95 meters. Subtract the space occupied by the post. Since our post is square, we have 20 posts in total, multiplied by its length is 0.20 meters, so the total length of the fence is 91 meter. So solve for the area of the fence, which is its height for the fence is 2.40 given here. Here 2 plus 0.40, then multiply that total length, which is 91 meters, then you have the area for the fence. And referring again to, this is the easy one I said earlier, because you only need to just multiply it to the given table, the 218.4, the area you calculated, multiplied based on the table, the 12.5, you can get the required pieces of CHB, which is 2,730. Based on this table, we have here the 12.5. Next is the cement mortar for block laying and cell filler. We again get the, referring again to table 2-2 using class B mixture, get the total volume, multiply the required values. You can compute for the required bags and volume for the sand and gravel. Next is the plastering. Again, it is just the same earlier. It's just that it had a lot of tables to base on. Then footing post, you can see here we have the footing post, which is 60 by 60. Since it's square post, so its footing post is also square. Then we can calculate the volume, the CHB footing, which is the total length of the fence is 95 meters, subtracted to the width of the post footing, multiplied to the 19 posts. Since we only need 19 posts because it's based on the post footing, not really in the post. So post footing, as you can see in the image, we have here the two are cut in the this distance of 5 meters. So if you add that, you can only have come up to 19 posts, because the two are cutted into half. Then again multiply by the cement based on the table. Then plastering again. So for the surface area of this area occupied by the CHB, which is 0.20 times 2, 0.60 times 2, height of the and the 20 post, the volume will be the area will be 24 square meter. This is for the plastering of the post if necessary. This 2 meters is the height for the post. Next is again referring to the table, the concrete hollow blocks, required pieces, bags, and you can calculate your required data. Next is brick masonry versus stone masonry. So the two are different in some ways. They have their own characteristics. Like they have brick have uniform shape, other than the stone masonry, which have not uniform shape and size. They are heavy, and also stone masonry are heavy in weight. They are much stronger than brick, because brick masonry is not much that strong. Example is of stone masonry and brick masonry structures. That's it. Thank you for listening.
In Sweet's report, she mentioned the definition of masonry, which is commonly used for the walls of buildings, retaining walls, and monuments. Now, its functions, first is it carry loads of ceilings, roof, upper floors. Also, it divide and define internal spaces and prevent vegetation, vermin entering interior, and also control or provide openings, access or lights or ventilation. In my report, I'll be discussing the cost analysis and the concrete hollow block. First, hashtag cost analysis. In this topic, I'll discuss the comparative cost analysis between a reinforced concrete wall and a hollow block wall. First, we define what is these two. For the reinforced concrete wall, it is a concrete in which steel is embedded in such a manner that two materials act together in resisting forces. In concrete hollow block wall, it is a large rectangular brick used in construction. Now, there is a common or ordinary question wherein some of the consultants are confident enough when asked by a client. First question would be, which is cheaper to construct, a reinforced concrete wall or a concrete hollow block wall? And the usual common answer is the concrete hollow block wall, sir. Now, the client will not end just like that. He or she will then ask, how sure are you that the CHB wall is cheaper than a reinforced concrete wall? And the consultant, without hesitation, would reply, I'm certain and sure for it, because it is already a proven fact, sir. And the poor client, with layman's view, has to believe whatever his consultant says. But not all clients stick to that answer. Of course, some will go for computations, some will really think of it or even Google it. Now this client is wise. These tables will be used in the computation. Table 1 to 2, the concrete portion. Table 2 to 2, quantity of cement and sand for CHB mortar per square meters. And next is Table 2 to 4, the quantity of cement and sand for plastering per square meter. And later on, we also will discuss about the Table 2 to 5 and Table 2 to 6. Problem 1. A firewall has a general dimension of 40 meters long and 8 meters high. Specify the use of 15 centimeter concrete hollow block with Class B concrete mortar mixture. We use Class B because it is commonly used in the Philippines. Now for the solution, this dimension is the standard product size in the Philippines, which is 15 centimeter depth, 20 centimeter height, and 40 centimeter length. First, we solve for the area of the wall. Length times width is equal to 40 meters times 8 meters, which is equal to 320 square meters. This table, we refer this to table 2 to 2. Now we use this for in getting how many pieces or quantity na kailangan. So 320 is the area times 12.5, which is in 15 times 20 times 40, na siya square meter na 12.5. In solving for the cement mortar, referring to table 2 to 2 using Class B, mixture 40 kilogram cement. For cement, area times its value, 320 times 1.013, which is equal to 325 bags. And for sand, 320 times 0.08438, which is equal to 27 cubic meter. Next is the cement plaster. First is to get the total area to be plastered. So this is the area, 320 times 2 faces, which is equal to 640 square meters. And in solving for the cement, we use or refer to table 2 to 4 using Class B mixture again, 40 kilogram cement. So for cement, 640, which is the area or total area, times 0.192, which is equal to 123 bags. And for sand, it is 640 times 0.016, which is equal to 10.2 cubic meter. Kaniya kay for concrete hollow block wall to siya computation, now we solve for the reinforced concrete wall. First is to solve for the volume of the wall. Volume, which is length times width times height, which is equal to 0.15 for 15 centimeter, name mo ng 0.15 meter using conversion, times 8 meter times 40 meter, which is equal to 48 cubic meter. And solving for the cement, we use table 1 to 2, which is the concrete portion, using class B concrete. Now, for cement, it is 48 volume, 48 na volume times 7.5, which is equal to 360 bags. And for sand, 48 times 0.5 is equal to 24 cubic meter. And for gravel, 48 times 1 is equal to 48 cubic meter. Comparing to the results we obtained from concrete hollow block, we got this. As you can observe, di lang na mag-stick ana, but we need to look for its equivalent prices or cost kung kinsa yun mas gasto. But in this report, I will not or no longer discuss to you the bill. After we solve for the cost, we then analyze first, for reinforcement, size and spacing, what is acceptable to CHB wall is more acceptable to solid concrete, so the cost is even or the same. For CHB wall, what is needed is lumber guide and scaffolding for the mason support in block laying. On the other hand, the reinforced concrete wall requires forms, frames, and braces. If forms are used on reinforced concrete works, what is needed is 1/4 or 1/2 of the entire area of the walls. Pouring of concrete could be done by sections. If plywood form will be used, 1/2 of the wall area will require. This is used in the concrete hollow blocks. 5. The dismantled plywood forms and lumber frames could still be used on the other structures. Therefore, its entire value could not be considered as part of the cost of the concrete wall because it also served on the other part of the building. For depreciation of the forms, 25% of its value could be considered in the cost of the reinforced concrete wall. Plastering of the reinforced concrete wall is minimal considering the fine finished surface of the concrete wall when plywood form is used. In terms of strength and durability, reinforced concrete is preferred than the CHB. And lastly, make canvas of the prices of the materials listed, plus your good analysis, your choice, and conclusion. And after that, decide on your own. In this problem, we will use table 2 to 5 and 2 to 6 to simplify further the estimating procedure in determining the quantity of the cement and sand required for CHB laying and plastering. In this table, the cement and sand for mortar and plastering is determined per 100 pieces of CHB, not by square area method as previously presented. First is to determine the area of the fence, which is equal to 2 times 6 equal 120 square meters. Referring to table 2 to 2, ang area multiply by 12.5 square meter, which is equal to 1,500 pieces. Next is we solve for the cement mortar using table 2.5 or the quantity of cement and sand per 100 CHP mortar. First, we divide 1,500 by 100 since it is per 100 CHB equal to 15. And then next is we refer to table 2.5 and class C 40 kilogram cement. So 15 times 6.72, which is equal to 91 bags. And in solving for the sand, 15 times 0.675, is equal to 10.125 cubic meter. For cement plaster, one phase body pod, mag-solve mo two phase, but in this problem, we will solve for one phase only. 40 kilogram cement, referring to table 2 to 6, 15 times 1.152 class C na pod, which is equal to 18 bags. And sand is 15 times 0.128. Sorry if di makita, but nana siya 128 and same rin na sila tanan is equal to 2 cubic meter. Next topic is the special type of concrete hollow blocks. First, we define what is concrete hollow block. Concrete hollow block is a hollow masonry unit with 2 or 3 cells or cores made of the following ingredients: water, Portland cement, and various types of aggregates such as sand, gravel, and crushed stone. Its advantages is it is readily available product, good thermal and sound resistance, high fire resistance, and can be reinforced to increase lateral resistance against earthquakes and typhoons. And there is a 20 plus years lifespan. So this is an example of a concrete hollow block. This table is the existing standards for CHBs and CHB wall construction in the Philippines. I will no longer discuss to you this, but I hope you make time to read and read. Next. The common and ordinary type of concrete hollow blocks are those with 3 hollow cells, as explained previously. However, there are concrete hollow blocks which are specially designed for architectural and structural purposes, manufactured by Jack-Built Concrete Products, as presented in figure 2 to 7. So this is table 2 to 7. For our estimating aid, table 2 to 7 was prepared to simplify the preparation of the materials required for block laying, such as the quantity of cement, sand, and gravel. The idea in manufacturing the concrete hollow blocks with 2 cells is to fill the hollow core with concrete. This is the hollow core, not just by a mortar for reasons of strength and economy. This is how the special type of CHB differs from that of ordinary CHB. The required quantity of gravel to fill the core was already incorporated in table 2 to 7. These are the blocks presented in Jack-Built Industries. First is the stretcher block, which is ideal for high-rise buildings that require load-bearing walls. L-corner block, its main function is to provide an interlock in the corners. And beam block, it is needed in structures that are open to strong winds and vulnerable to earthquake. Sealed end block is similar to stretcher block, but it is designed primarily for partial grouting. Notice that the end base is intentionally sealed. And for half block, it is designed primarily to eliminate the nuisance and inconvenience of cutting blocks in half. Lightweight block, it provides aesthetics in architectural finish for walls and partitions. Paving block is an alternative to conventional paving and concreting. It is designed for easy installation and maintenance of pavements. Thank you for listening. Have a nice day, everyone.
So, good day everyone, we are now in part 3 for the topic Masonry. So, Masonry is a variety of materials combined with mortar of varying strength that can be used for masonry construction. Some of the common materials used are bricks, stones, concrete, veneer, gabion, etc. Here are the 6 types of masonry construction. We have here brick, stone, concrete, veneer, gabion, and composite masonry construction. And this brick masonry construction and also concrete masonry constructions are two of the widely applied type of construction, especially in building constructions. Now, for its advantage, the use of materials such as bricks and stones can increase the thermal mass of the building. And masonry is also a non-combustible product, which means that it can protect the building from fire. That's why in some of or most of the residential buildings are building firewalls. Next is masonry walls are more resistant to projectiles such as debris from hurricanes and tornadoes. It also has some disadvantages. First is masonry tends to be heavy and must be built upon a strong foundation such as reinforced concrete to avoid settling and cracking. So it needs a lot of planning when it comes to the foundations, especially for columns, footings, and other types of structures. Then next is, other than concrete, masonry construction does not lend itself well to mechanization and requires more skilled labor than stick framing. So it is not easy to do, and it needs a lot of skilled workers. And next is, masonry consists of loose components and has low tolerance to oscillation as compared to other materials such as reinforced concrete, plastics, woods, or metals. Then adobe stone. By the way, adobe stone is one of the type this belongs to adobe stone belongs to brick masonry construction. Adobe is essentially a dried mud brick combining the natural elements of earth, water, and sand. It is an ancient building material usually made with tightly compacted sand, clay, and straw or grass mixed with moisture, formed into bricks and naturally dried or baked in the sun without an oven or kiln. It is ordinarily used as fencing materials as substitute to the concrete hollow blocks for economic reasons. But lately, the use of adobe stones was no longer limited to ordinary zocalo and fencing works, but also extensively used as finishing and decorative purposes for exterior and interior of the building structures. This is the form of an adobe stone. Now we are given the tables for constant multiples in order to calculate for the different components of adobe stone in constructing adobe stone like fencing or other types of structures. Then we have here given multiples in order for us to calculate for cement and sand. Now for example, this figure, from figure 228A, compute the quantity of adobe stone, cement, and sand using class C mixture. So first, you need to determine the net length of the fence minus the space occupied by the buttresses. So this one are the buttresses. This we have here 4, or because we considered half, we have here 3 total of buttresses. So we need to add these 3. We have here 15. Then subtract the portion that is covered by the buttress, which is this portion, this portion, this, and this portion. So the area of this, the measurement of the said portion is 0.3. Multiply it by 3 because we have here 1, 2, and a total of 3, 2 halves, total of 3 posts. So the total net length of the fence, this is 14.1 meter. Now for the net area, we just need to multiply the net length by its height, which is given as 1.5 from top to ground line and then 0.5 from ground line to the footing. So we have here 28.20 square meters. Then referring to table 2.8, using 15 by 15, this one using 15 by 15 by 45 centimeter stone, you just need to multiply the net area by 12 here. So we need that to be equal to 338.4 and round it up. So we need 339 pieces of adobe stone for our fence. Next is for the we need further calculations for uh, Adobe stones. Now this time it is for our buttress. So the total height of 4 posts or our buttress is 1, 2, 3, 4. The total height of that is 2 meters from the footing. We have 4, so 2 times 4 is equal to 8. Now from table 2, 9, using 30 by 45 buttress, this one. Using 30 by 45 buttress, we need to multiply 8 by 12 pieces. Is 12 pieces per meter of height. So we need 96 pieces from this top up to the from the bottom up to the top of the wall, the post or our buttress. We need 96 pieces of that. Then plus the Adobe stone footing per buttress or post. So we have here 1, 2, and 3, 4 from the other side. So 4 pieces, and we have here 4 posts. So 96 plus 4 times 4, that will be equal to 112 pieces. We need 112 pieces of uh, Adobe stone for our post and also for our footing. The next is determine the length of the fence less the area occupied by the buttress footing. So 15 meter plus the 0.45 by 3. This 0.45 by 3 is the area occupied by the buttresses in these sections. Buttress footing in sections. So that would be equal to 13.65, and then multiply it by 6. That would be 81.9, or say 82 pieces of Adobe stone. Now we are done with calculating our number of Adobe stones. We're moving on to cement mortar, calculations of cement mortar. First is we need to calculate for the wall fence area. The wall fence area was calculated already above, which is 28.20 square meters. And referring to the table 2.8, using a Class C mixture of 40 kilogram cement, this one, multiply the area by 0.2106. 0.2106, that will be equal to 5.939 bags of cement. Then for sand, we have here to multiply it by 0.0234, that will be equal to 0.6599 cubic meter of sand. Now for buttress and footing, we have area equal we have here 112 pieces of Adobe stone. Referring to table 2.9, Class C mixture is Class C mixture 40 kilogram of cement. By the way, we are now calculating for the block laying. So we have to multiply 112 by 0.0203, is constant multiple. This will be equal to 2.274 bags of cement. Then multiply 112 by 0.0225 equal to 0.252 cubic meters of sand. Then next is for footing. We have here 82 pieces. Referring to table 2.9 again. So we need to multiply by 82 by 0.0203, same as above, 1.665 bags of cement. Then we have here sand equal to 0.1845 cubic meters. Now for cement plaster, we need to determine the total surface area of the wall plus the surface area of the buttress to be plastered. One face only, so we need to add 15 meters for this total. We will need to plaster this one. Then plus 0.45 this area, this surface area here. Then plus 0.15, here 0.15, 0.15, 0.15, 0.15. We have here 0.15 times by 8 because we have here 8 faces. So calculating, we have here 16.65 meters of length to be plastered. Then solving for the area, the area of that will be length by its height, which is 1.5 meters from the ground line up to the top. 16.65 by 1.5, that will be equal to 24.975 square meter. Now referring to table 210, you just need to multiply the cement by 0.225. We are still using class C at 40 kilogram, so we need to multiply it by 0.225. Then that will be equal to 5.619 bags of cement. Then multiply the sand by 0.025 equal to 0.624 cubic meter of sand. Now multiply the result by 2 only if you have two sides that you want to plaster. So if you only want to plaster one side, so you don't need to multiply it by 2. Now say we plaster both sides of our adobe stone, so we need to multiply it by 2. That would be equal to 11.238 bags of cement and then 1.248 cubic meters of sand. Summarizing, in order to build these entire structures in figure 28A, we need an adobe stone of 533 pieces, cement of 21.12 or round up to 22 bags of cement, and then sand of 2.35 cubic meters. So we are now in decorative concrete blocks. Decorative concrete blocks are made out from either cement, mortar, or clay. These construction materials have been widely used for ventilation and decorative purposes only. So these are the examples. And we are not gonna calculate the quantity of this anymore because it is not that commonly or widely used blocks, especially in constructing uh, buildings and residential for walls, and because it is just for decorative and ventilation purposes, and it is not that applicable in areas wherein hot climate or hot weather is expected. Then, but still we are given a table on how we can calculate for the said quantity, but it is just the same with the way we calculated for the different like say our Adobe how we calculated our Adobe stone masonry. We are given with multiples here in the table. Say for example table 211, we are given the multiples on how we can calculate for the quantity of decorative blocks, cement, and sand for block laying mortar. Then also table 212, quantity of cement and sand for various types of bricks and stones per 100 blocks. And these are the types of decorative blocks: Italian, Bolivian, Luz, Corinthian, Roman, Giuseppine, ESG, AUM, Egyptian, and Persian. So thank you for listening. That's all.